Hello, ladies and gentlemen. Today we are going to take a look at beginning our fourth unit here, and one of the skills we need to be successful in this next unit is that of factoring. So today you need something to write with, the foldable notes that you got from class, possibly a calculator, and definitely your thinking caps as we explore this idea of what it means to factor. So let's first take a look at what you remember about multiplying. Now notice earlier this year we took things like x plus 3 times x minus 1 already. When we did that, we'd do a double distribute. That is, we'd take x times the x and create an x squared, x times negative 1, making negative 1x, 3 times x, giving me 3x, and 3 times negative 1, making negative 3. Now notice when I multiplied these two things times these two things, or two pieces over here, I ended up with 4 pieces, but I in fact could combine these two middle ones to create 2 x's in the middle. This is an expression that I created through multiplying. Keep that in mind as we go on and take our notes in that foldable today. What does it mean then to reverse this process? And that is, what does it mean to factor? So the word factor, let's take a little brief look at what that looks like in many different contexts. You know, many people quote the word factor quite often. You know, character in the long run is the decisive factor in the life of an individual and nations alike. Theodore Roosevelt said that. He's talking about a factor. And confidence being a factor from Jack Nicklaus, the golfer. Now, what about the dictionary? Well, the dictionary, dictionary.com, talks about it being an element or a constituent, what makes a thing it is. So it's a part that makes up a whole, if you will. In the math world, we're going to look at what that factoring entails and also some different strategies we use to factor. So this is your foldable here, and this is where your notes start happening. You need to be able to take down these notes within this outline. You will fold it over as I've given you the papers already. You fold it over. We put a couple little staples right up in here, right? And we make this little booklet. And when you flip up the top page, you're going to have a space to write. So this is what we need to write in that top page. When you fold it, here would be your fold line, fold it open. It gives you some space to write these things. To find out what was originally multiplied to create the expression, what we're doing here when it means to factor is to undo that multiplication. We're going to undo the multiplication process and write it as a product of factors. So I give that same example, that same idea here. If I have x squared plus 3x minus 4, this has already been multiplied out. Something was multiplied to create this expression. This is written in a form where it's an expression that is not factored. But I can create an equivalent expression or create a factored expression by writing it as a product of two factors that multiply out to create this. That's what it means to factor. That's the process that we'll be doing here. And we're going to go about it through all of these ways on the page, through greatest common factoring, through group factoring, through trinomial factoring, and through difference of perfect squares factoring. So let's take a look at what it means. Open up that next page for greatest common factor. For greatest common factor, we're looking to do a specific skill in order to break apart and factor something using greatest common factor, or GCF. When we ask ourselves about greatest common factor, we say, what is the largest number or variables, or both, that can be divided out of each term in the expression? So that would be what I would write on top. This would be the fold line here, perhaps, right? And then underneath here creates a lot of space where you can write 3 examples that we're going to do. Those 3 examples look like this. Okay, example 1, example 2, and example 3. What we need to do for each of these is factor them, or undistribute essentially, for each one using greatest common factor. So for example 1 here, I have 3 terms. I have a 6x squared, a negative 12x, and an 18. And I need to ask myself, what is the largest number or variables, or both, that can be divided out of each term in that expression? So if I look just at the numbers first, I have a 6, a negative 12, and an 18. What's the largest number I could divide out of all 3 of those terms? I could divide all of those numbers by a 6. Now I should look at variables. Variables for each of them, this has an x squared, this has an x, this doesn't have any variables. So in fact, the only thing I can divide out of each term evenly here is the number 6. And so once I've decided what I'm going to divide out, then I write it out in front of the parentheses, like it was likely written before it was distributed, right? There'd be a number in front of some parentheses. And now I need to literally divide each of those terms by the number 6. So 6 divided by 6 becomes 1. So this now becomes 1x squared. What about negative 12 divided by that 6? Becomes negative 2. And then the x is still there. What about 18 divided by the 6? Well, that becomes 3. So this expression is now written in factored form. The 6 is the greatest common factor that we divided out, but both of these together make up the factors that get multiplied to make that expression, or that could get multiplied to make that expression. Okay, let's look at example 2 here. Same idea. This time I only have two terms, 14x to the fourth minus 7x. What is the greatest number I can divide out of the 14 and the negative 7? I could divide out a 7. Now let's look at the variables. This one has an x to the fourth, this one has an x. I can divide an x out of both of them. They both have x's that I could divide out. So I'm going to write x right here, and now I can go ahead and literally divide both of these terms by that 7 and the x. So 14 divided by 7 would make 2. X to the fourth, but if I divide one x out, it now becomes x to the third. Now let's do negative 7 divided by the 7 is negative 1. The x was here, but now I divided that x out, so now he's no longer a part of that internal expression here. So again, the 7x represents the greatest common factor, but the two parts, the 7x and the 2x to the third minus 1, are really what make up the factors of that expression. So example 3. This one has x's and y's in it. Look at that. So 28x squared y plus 16x to the fifth y plus 8xy squared. Well, let's take a look at just those numbers. 28, 16, and 8. What's the greatest number that I could divide out of each of those numerical values? Or what's the greatest coefficient I could divide out? I could divide all of those by the number 4. So if I pop a number 4 out in front, that'll be a part of my greatest common factor. Now let's look at the variables. Notice just x's this time. This one has an x squared, this one has an x to the fifth, and this one has just one x. So the greatest amount that I could divide out of each of them, and they'd still have enough to divide, would just be 1x. Now let's look at y's. I have one y, I have a 1y, and I have a y squared. So I'm going to divide out a y from each of them. And now let's literally do that. What's 28x squared y divided by 4xy? Well, let's just do one piece at a time. 28 divided by 4 would make 7. X squared, divide 1x out, leaves me with an x. Y, divide the y out, I have no more y's. Okay? Now let's look at the 16. 16 divided by the 4 is a 4. X to the fifth, I'm dividing 1x out, so now it becomes x to the fourth. 1y, but I divided that y out. Y divided by y would be 1, so no changes. There we go. Plus sign gets written in again, and now let's do the 8. 8 divided by 4 is 2. X, divide the x out, so we have no more x's. This one had a y squared, but I divided one y out, so there's just one y left. Okay, so again, number in front here is the greatest common factor, but both of these parts are equivalently important or equally important here, as they both are factors of this original expression. All right, so that's greatest common factoring. What about when we do group factoring? This will be the last one we do in this video. Group factoring is something that you do when you have 4 terms. It's something that's easily done with 4 terms using that greatest common factoring technique. So you group into pairs and you factor out a greatest common factor from each group. Factor what is common one more time, and then you end up with your final expression. So here are 3 examples. Again, maybe this is your fold line, or you can fit these 3 examples in there when you flipped up that page. And this one we're going to do factor by grouping. And again, this is easily done when there are 4 terms. So 4 pieces make up each of these expressions. And now when you factor by grouping, we're going to group into pairs. This is probably a flashback to your Algebra 1 experience. You factored both of these ways in Algebra 1 as well. So I'm going to group these first two terms together. 2x to the third plus 12x squared. And now I'm going to do greatest common factoring for just those two. What number can I divide out of both of those? I can divide out a 2. How many x's or what exponent on the x's can I divide out? This one has an x to the third, this one has an x to the square, or an x squared, so I can divide out an x squared. Now let's literally do that for those two terms. 2 divided by 2 is 1. X to the third divided by an x squared leaves me with an x. Now plus sign. 12 divided by 2 is 6. X squared divided the x squared out, so there's no more x's there. So out of these two pairs, I divided out a 2x squared and was left with x plus 6. Now I do the same thing for these last two. What are these last two terms? What can they be divided by? Well, I can divide a -5 out of both of them. -5 and -30 can both be divided by -5. And if I do that, what would it look like? -5 divided by -5 would be 1, x left. -30 divided by -5 would make positive 6. So we grouped into pairs and we factored out the greatest common factor of each group. Now we factor what is common one more time. So notice that in this problem, see how that x plus 6 is repeating in both parts of my factor here? I'm going to factor out an x plus 6 from both halves of this problem. So my x plus 6 gets factored out, and what's left? What's the leftover pieces here? That'd be this part and this part once I factor out that x plus 6. So my other factor would be x squared minus 5. So one factor is x plus 6, the other factor is x squared or 2x squared minus 5. Both of these are my factors. Okay, notice one part was the repeating and the other part was the leftover stuff that we pulled out, or the greatest common factors. Let's do another example like that, maybe just a little bit faster here. Let's partner up these two. So on this one, what can I divide out of those two terms? I can divide out a 2x squared. What does it look like, or what happens to these two terms once I do that? 2x to the third divided by 2x squared would leave me with 1x. 4x squared divided by 2x squared, 4 divided by 2 would be 2, and the x squared divided an x squared out, I'd have no more x's left. What can I divide out of those two terms? Well, they both don't have x's, and they don't have numbers that I could literally divide out there. They both don't have 2's or 4's, but you can always divide by the number 1. So I'm going to pop a 1 out in front here, a positive 1. Now if I divide both of these by positive 1, they are not going to change. It's still x plus 2. Now notice I have the repeating factor of x plus 2 here, so if I factor that out, x plus 2 is the repeating part. The leftover stuff here is 2x squared plus 1. Both of those are the factors that were multiplied to create the original expression in example 2. So if you wanted to distribute this back out, you could check and make sure that it equals what that problem looked like to begin with, okay? Last one, example 3. We got x's and y's in here. Here we go. We can do this. Partner the first two here. What number can I divide out of both of those? I can divide them both by the number 3. This has an x squared. This has an xy. I can divide just an x out of both of them then. They don't both have y's and they don't both have x squareds. Just one x is all I can do. So what would that look like once I do that? 12 divided by 3 is 4. X squared divided x out is 4x. Now let's go to the second part. Divide this by the 3, so that's 3. X comes out, divide it out, and I'm left with just the y. Love it. So that factors into 3x in front, 4x plus 3y. Now we go to the next two terms. What can I divide out of those two? Well, notice that they're both negative. Is there a number you can divide out of -4 and -3? Just -1, right? There's nothing else I could divide out of them evenly. What about variables? I see this one has a y and this one has a y squared, so I could at least take a y out. Then what would it look like if I did that? -4 divided by -1 would now be +4. Divide the y out, I have 4x. Now, negative 3 divided by negative 1 is positive 3. Y squared divided a y out, so now it's just y. Look at that. Do you see the repeating part? One part of my factor is 4x plus 3y. That's the part that's repeating in both terms there. And the other part would then be 3x minus 1y. These pieces here as part of my greatest common factors. Very nice. So now we've worked on our factoring with AC method and factor by grouping. These two strategies are ones that are going to be continually used as we continue down this method list here, but we'll start just by working on these two. Thank you for taking good notes today. I'll see you later.